we have a few more examples to go through to complete lesson 4. So we are going to go through them now. We're starting with example 3. Can anybody remind me of what we were learning about at the beginning of this lesson? Basically yesterday, what did we learn about? Yes?
The girl with the meters has to jump over the line.
Yeah, that girl was trying to beat those scores. But what kind of equations were we working with?
Hold on.
Starts with an I.
Great. Inequalities.
Inequalities, very good. So, very much like an equation, but they have a very special name because there isn't just like one answer for x, right? It's not just like x equals 2, it might be x equals, or x is greater than 2, so it's more of a set of answers. Very specific set, but it's kind of like a big group that could be anything over 2, okay? So that's what we did yesterday when we had very clear inequalities. Today, I promise you it's not hard, you're gonna love it. It's not hard at all. But it's gonna sound hard when I say it. We're going to explore what happens when we're dealing with inequalities, but now we're not dealing with one solution set. Like x is greater than 2, so that means that it's like anything over 2, okay? That was one solution set. We're gonna deal with inequalities that maybe have all the solutions in the entire world. We call that infinitely many solutions.
What?
Infinitely many solutions. Remember when we did that with equations?
No.
Yes? Remember when we had an equation, the equal sign was in the middle?
Oh, yeah.
And then we ended up canceling out the x terms, and then all we had was like a number equaling itself. And because that was a true statement, we called it an identity, right? It was like a 6 looking in the mirror and seeing itself a 6. The equation was true, so we said, well, technically, all real numbers could be x, any real number. Then we also had a situation where we would end up canceling out our x values, and then we'd get something that says like 5 equals 8, and we're like, nah, that's not true. So what does that mean for the value of x? No solution. Now, inequalities, just like I said, they're very similar to equations. And we are going to explore the world of infinitely many solutions or no solutions today. Let's see what this is. I know the book kind of spoils it, but let's do it together, okay? I'm going to solve it over here. If I'm writing, you're writing. Yep. We're going to solve this for x and then see what happens. If I'm writing, you're writing. Did you get it down yet?
Yeah.
Oh, okay. All right, so what do? We're just going to breeze through this part. We're going to treat it like an equation. Don't forget that twist if we're dividing by negative. Go ahead.
I know. We distribute negative 3 to 2 and
Good.
5. It becomes negative 6x
Good.
plus 15 is greater than negative 6x plus 9.
Oh my gosh.
What?
Give this guy a round of applause. That was really
And then
good.
what we do next, we add 6x to both sides,
Sure.
and then it cancels it out, and then it equals 15 is greater than 9.
Oh my gosh. He's
I already
pretty
did
good.
the problem way before you did.
Oh, really?
You were in the middle of talking, and I finished it.
Oh, okay, that's wonderful. All right, so notice how we end up canceling out our x terms because we have a negative 6 here and a negative 6 there. When we add 6x to both sides, it cancels out. So now we have 15 is greater than 9. But where did the x go? How do I find the solution for x?
That is the solution.
There is no solution.
No, that's not true.
That
I
is
know
the
it kind of seems like that, right?
But it's no
Seems like
solution.
it.
Divide by 9. All real numbers.
No, yes. Because look, we're just looking to see, is it a true statement?
Yes.
Just like with the equations, when it said 6 equals 6, was that true?
Yes.
Then there were all real number solutions for x. So if you have a true inequality, if 15 is in fact greater than 9, then your answer is all real numbers. All real numbers will work for x, because no matter what number you choose, let's say I plug in a 2 for each x. Let's say I plug in a -10 or a 15.963. No matter what number you plug in for your x value, you'll end up with a true inequality. Your numbers might end up different, but we're not worried about what the numbers are. We're worried about, is this true? If it's true, it's all real numbers. You good? Now, I had a question last period that was,
What do you do after distributing? Like after you distribute?
yeah.
Because I keep getting lost after you like figure out what the answer is after distribute.
Okay, I'm gonna distribute again. So -6 plus 15 is greater than -6x plus 9. So you're saying you kind of get stuck like with what to do next, because this is a common place to get stuck, because we do have plenty of options. And I'm glad you asked, because I'm actually gonna show you the other option. There are 2 options that we can do here. Technically there are 4, but let's go through the 2. What Grayson suggested was that we add 6x to both sides. Totally great option. You might go, but can't we also subtract 9 from both sides? Is one more important to do than the other? No, not necessarily. We can solve it this way too. So sometimes when we have a choice to what to do, we think that we're stuck. You're not stuck, you can just choose. So let's solve it this way now, and I want to show you something. When I cancel out my 9s, and then I get, I have a -6x, right? Plus 15 minus 9, 6. Greater than -6x.
Ooh, there's also
You divide.
Plus 15.
What?
What?
Plus 15. Or
No, plus x on both sides.
Oh,
Yeah,
my bad.
I still have to take care of my x terms, right? I know they're the same and it's freaking you out, but we have to take care of them. So let's add 6x to both sides. Any way you slice it, your x terms are going to get canceled out here. But what did it cancel out to?
6 is greater than 0.
Yes, 6 is greater than 0. Do I care that my numbers are different? Before it said 15 is greater than 9. That was a true statement. Is this a true statement?
Yes.
Yes. So is the answer still
Yes.
all real numbers? Yes.
So if that question was on a test and I put 15 is.
If the question was on a test, the answer would be all real numbers. It wouldn't be anything
Yeah.
like this.
It's like it's.
It would
what's on the
probably
homework.
be a multiple choice, and if it were a fill-in, you would write all real numbers. You wouldn't have to show any of this, because it technically could be a lot of different types of true statements, but that's a really good question. All right, I want you guys to try one on your note. Nope, we're gonna do another example. Yeah. Yeah. And if you happen to see a maintenance person or a grown-up that could find a maintenance person, ask them to bump the air a little bit colder, because we're dying in here.
Can I do this one?
Oh, really?
I thought that was just me.
No, I'm dying.
It's
Okay.
so hot in
You want
here.
this one? Well, you just did that one. Let's give somebody else a chance.
To get sick and tired.
Yeah.
If I get too hot, my head
Technically
gets
the eighth, but I don't know. Ooh, it just got very chatty in here. Thank you to the people who are still focusing and copying. All right, we're gonna solve this one. You know how I have to write it on my own, because I do not like the way the book works. 2 times 2x equals 3. Make sure you're copying, okay? All right, what do we do?
distribute.
Distribute, okay? So this part stays the same for now, so just call it out. 4x minus 5 is less than what?
Oh, sorry.
call it out.
4x minus 6.
4x minus 6. You guys are getting very good at remembering your rules about multiplying integers, positives, and negatives. I think you guys are getting really good at that. So now what do we do?
Minus 4x on both sides.
Sure. That's what I like to start with to continue to answer your question, Charlotte. I like when I notice that my x terms or my variable terms are the same, I kind of like to take care of them first. It makes it a little bit simpler for me, because I kind of just like to wipe them out.
Ooh, that is
And then I can just compare the numbers. negative 5 is less than negative 6. Now here's where you have to
It's
think.
wrong. It's wrong.
You have to
No,
think because
no.
you're like,
Yes.
your brain is gonna wanna think positive numbers for a second. And I'm sorry, I know it's
Oh
very
yeah, it is wrong because -6 is less than -5.
correct. If you think of a number line, right?
We're going backwards.
Yeah.
It's
If
backwards.
zero's here, -1, 2, 3, 4, 5, -6 is over here. This would be -5, this would be -6. So to say that -5 is less than 6 is not true. If that's not true,
No
then no solutions. And that means that no matter what value you put in for x, you'll always get a false statement at the end.
Those ones are a lot easier than the ones we did yesterday.
Just wait for the word problem that we have to do.
Uh-oh.
It's not hard, it's not hard, I promise.
So if we do it the other way, it's just gonna be only answers.
Yes, they do.
What do you
I
think?
did the other.
Oh, yeah, the air.
So
So
you
you subtract,
I can't hear him.
if you subtract 5x, and you subtract 5, and you subtract.
Oh, you mean if we did it the other way? It would still be the same, yeah, we can solve it that way. Let's see what happens. Let's see what happens if we don't take care of the 4x at first, okay? So then we have 4x minus 6,
Do we
okay.
have to?
Do we have to
Makes
do what?
sense to us? Do we have
Oh,
to?
you don't have to write this down. This is more of like an explanation. Okay, so let's say we're just gonna leave our x terms alone for a second. Let's just say I wanna add a 5 to both sides. Then I have 4x is less than 4x minus 1, right? Now what do?
Oh.
You have to deal with your x terms now,
you,
right?
You minus 4x on both sides, and
minus
that it would be -1 is less than 0.
Well, no, let's read it from left to right first,
Oh, so
okay?
it'd be
So
0
0.
is greater than.
No.
Oh.
We're minusing, not dividing, so we don't have to change this.
So it'd be
0 is less than -1.
But that's
Totally different statement,
it's false.
but it's still totally false, right?
What if you add the
Add the one.
So does it matter which way you
Okay.
do it?
If I add the 1 to both sides, we're just kind of making it a little more complicated, but if I add the 1 to both sides, I cancel this out and I get 4x plus 1 is less than 4x. Then I still have to subtract 4x
Yeah.
and I get 1 is less than 0.
Yeah, that makes sense.
Still untrue. No matter what you do to this problem, it's gonna just keep lying to you, right? It's false. So if it's false, it is no solution. They're very good questions. You guys are thinking very deeply and I love it.
So does it matter which way you do it?
Doesn't matter what order you do it, you might come up with completely different numbers than him, and he might come up with different numbers than her. As long as all of you are correct in saying it's a false statement, or all correct in saying it's a true statement, then you'll come up with the correct answer. Because the answer to the problem isn't the statement, it's the conclusion. It's the all real numbers,
What type of
no solution, or one value set like x is greater than 2, or whatever.
Can I do another one?
You guys are gonna solve these on your own now. I want you to do A and B. And remember, what I'm looking for, I'm not looking for your statement values, like 2 is greater than 1 or anything like that. What I want is you to work it out, decide if your statement is true or false, and then write whether it should be all real numbers or no solution because of that statement. Okay?
Because of what? I'm sorry, I was writing down.
It's okay. You're gonna solve these, you're gonna end up with an inequality statement. If it's a true statement, it's all real numbers. If it's a false statement, it's no solution. And that's the answer I'm looking for, either all real numbers or no solution. You have to work it out first.
I just have to remember what an inequality is.
Okay. Are you done already?
No, but I have a question.
Yeah, just hold on one second.
Is negative times negative still positive?
Yes. Okay, so what I just said, you have to write it down. because I don't want it said out loud.
I'm sorry.
It's okay. I don't want answers said out loud, it's distracting for other kids.
Oh, I didn't finish. Are we allowed to collab?
Yeah, you can collab if you want.
Who's number one?
Good. Wait. Wait. No. Is this a true or false statement?
Can I see?
I'm gonna give you guys a hint.
Is
A is really tricky because you're gonna look at your inequality statement and you're gonna be like, it's kind of true, right? Is it really true? Take a look.
No.
Take a look.
So,
What if I'm supposed to?
Baloney.
That is correct.
Wait, I got.
I love how you just went ahead and like subtracted 4. You didn't have to. You could just go for your 4 is less than 4 statement, but you were just subtracted 4. You're like, I'm gonna make a 0 is less than 0.
Just like I got.
You got it. No, you just copied it wrong. It says negative 8x up there.
Oh, let's see.
I got 4 is less than 4, so there's.
Just say yes and keep going. Yes.
Just like I got.
Is this A? Wait, where's A? So, this is correct. This, oh, that's good. This is correct.
Is that you?
No, that wasn't me.
Good. And the correct way to write that. Even this is correct, it's the correct statement. I'm just going to
Oh,
write
shit.
it.
What I do?
Because when it is infinitely many, we would say that x has the value of all.
I know, I forgot to take that out.
So it's switched around. What is happening? So where's, this is A? All I want to know is which is A, which is B here.
Wait, no, this is
Okay, good. All right, we're going over it. I know you have a question, but I have a few more things to
I was just
do.
wondering, when the negative and the positive combine, it's still positive, right?
No, the negative and the positive combined.
Like when you
add them,
Yeah, if you like distribute.
are we adding or are we multiplying?
Multiplying, so.
Okay, so when you said combine, that means add, so.
I'm sorry, I'm
Are you talking about this?
No, I'm talking about B.
Oh, B?
Yeah, that would
So
still
it'll
be
be a negative.
like, that'd be whatever it is, plus whatever it is.
No, it would be negative.
Who is
Guys, this would be a negative 6x.
Yeah, I know, and
Not
then
the 1.
the one.
And then a negative 3 plus a 1 is a negative 3.
I know, but I was wondering if the positive would stay positive or not.
If what positive would stay positive?
Plus 1.
Like plus one.
So negative
Like when
3,
you distribute
it would be
something.
negative 6x minus
Okay.
3.
Can you
That's what I
please
mean.
see if this is right?
I'm gonna tell you guys, I'm not worried about your statements because they're all gonna be different. But I am gonna tell you that you might have gotten 0 is less than 0, you might have gotten 4 is less than 4,
That's what I got.
and that might have confused you because we haven't worked with something where we have the
No
same
solution.
thing, right? And you're like, oh, is it an identity? Like 6 equals 6? No. 6 equals 6 is true. 4 is less than 4 is not true. You can't have $4 and say that that's less than $4. That's not true, okay? So this is not true, therefore, no solution.
I got it.
This one, give me an example of your inequality.
-5 is less than
It's a big case from a tiny person. What? No. What I want is your final inequality, your final inequality statement.
That's what
I got 0 is less than 2. What did you get?
I get a negative.
-5 is less than
It's okay if you didn't get this. There are going to be a couple of different kinds. What did you get?
-5 is less than -3. That's what I got.
Good.
What do you think numbers right there?
Just the way we solved it. Shh. It's okay to get different ones. What are we saying about this? Is this true?
No.
Yes.
Is 0 less than 2?
Yes.
Is $0 less than $2?
Yes.
All real numbers.
Is -5 less than negative 3?
Yes.
Yes, these are true, therefore all real numbers. Okay? I need to move on. Because I know how much you guys love word problems, so I want to give you word
So
problems.
much.
Okay, fine, we'll never do word problems in class, and then you can just, good luck on your test. Would you like to do word problems so you know how to do them?
Yeah.
Okay, good. Then I shall, thank you for asking. Shh, I need it silent, I don't have a lot of time, and I want you guys to practice this one on your own too. Derek is feeling romantic, okay? He'd be online shopping for some roses, okay? He's checking out the roses. But he's also a little cheap, okay? So he wants to buy roses for his girlfriend, to impress her. But he's poor, and he wants to find the best deal. So he wants to order roses. Has anybody ever seen blue roses before?
Yes, they're so pretty.
They are really pretty. Okay,
I have some.
so stay with me. He's buying these roses online and he sees a couple of different options. Option A from this florist. It says it's only $4.75 per rose, but we charge $40 for delivery. Sorry. Oh please, if you've ever had to buy flowers for somebody, it's like so expensive. It's like just make them cookies
Not if you
instead.
go to the dollar store.
Oh, real flowers are fake. There you go. And
They
they
last
last forever. Okay. Florist B. Ooh, pricey red roses. $5.15 a rose, but they only charge $25 for delivery. So do you see how Derek's in a conundrum? He's like, I got this lady and I want to impress her, but I don't know which one to go with.
Not one big
It really depends, yes, on how many roses he wants to buy, right? Shh, oh, there's so much talking. And I'm not done telling about my buddy Derek over here. We gotta help him out. We gotta help Derek figure out what he should do. So are you gonna listen?
Yes.
Okay, let's help him figure it out. We used to solve problems that were like, how many numbers of roses would make florist A equal to florist B? And then we would just make 4.75 R for rose or X for rose plus 40 equals 515 X plus 25. But we're not trying to find what would make them equal to each other. Lily, doesn't seem like you're on task right now. I really want you to be on task. You know why? Because I really want you to know how to do this stuff when you have to do it on your test, okay? Thank you. Back to Derek. So that would be if we wanted to make them equal. But what this is saying is what number of roses would make it less expensive to go with florist A, okay? We want florist A to be cheaper or less than florist B.
Why do we want to?
Just because he wants to explore his options, it will make sense as we go through it a little bit more. I can't take questions unless it's really, really important because I am gonna show you how to do this, okay? We're going to compare the cost of a certain number of roses at florist A with the cost of a certain number of roses, the same number of roses, at florist B. But we want them to be less than, to see how many roses would make more sense to go with florist A, okay? So we set up our inequality. We have 4.75 representing the money, X representing the number of roses, and $40 representing what?
Shipping.
The delivery charge or shipping, whatever it is. Okay, then we have less than, because we want to see what would make florist A less than florist B, okay?
Oh, that was on like
5.15X plus 25. This represents florist B. Are you with me? So, treat it just like what we've been doing. Treat it like an equation. Be careful if you have to divide by a negative, but I don't think that's the case here. Let's see. What should we do first? Couple of
Subtract
choices.
4 to the 5.
What?
Like take the 4, put it on the other
I don't
side.
see a 4 anywhere.
4.75
Sure,
is
okay.
what I meant.
Minus 4.75x, girls. Minus 4.75x. Cancel. Now we have 40 is less than what is this? It's 40? 40 cents. 40 cents. 40 cents. So I'm just gonna put 0.4x plus 25. Next.
Subtract 25 to 40.
Subtract 25 on both sides. And we get 40 minus 25 is that 15? Less than 0.4x. That cancels out. No negative, so we're gonna keep our inequality sign just the way it is. Divide by 0.4 on both sides. Stay with me here. This is going to seem a little bit complicated. I promise I will walk you through it if you're paying attention and taking notes, okay? Okay, good. So, cancel. Somebody divide this for me. 15 divided by 0.4.
15 divided by 0.4. 3, wait, hold on.
37.5.
Okay,
It's
Yeah,
X is
37.5.
greater than.
you're right. Hold on. 37.5 is less than x. Let's evaluate what this really means, okay? If 37, and don't worry about the roses right now, 37.5 is less than x, how can we say what the value of x is? X is greater than 37.5.
You have to do that.
Why did I switch them? Because I switched my values, right? I'm just reading it the other way. I can, shh, guys, come on. I can read it this way. X is greater than 37.5. So I can write it that way too, just to help my brain understand it more. X, which is the number of roses, has to be higher than 37.5. So how many roses would that be to make it cheaper?
I don't know.
37.6 or higher.
Well, do you buy roses by the point to the 10th of a rose?
So 36.
What would it be?
38.
38 roses or more would make it cheaper. So 38 roses or more, or I should say 38 or more roses would make A cheaper. So we don't even have to solve an inequality for florist B. Watch what happens. If buying 38 or more roses makes this cheaper, then what would this be?
38 or less.
37 or less. Very good. Because they can't both be 38 because one's cheaper. We have to deal with what's cheaper. So 38 roses or more, 37 roses are less for florist B. What? No need to graph. So what I do want you to do is, this is your question, but I'm gonna back up because you need this information. It is 5:20. Okay, so what we're gonna do is I want you to find out what it would be if they changed the price to $5.20. Okay? So I want you to find out how many roses, you can do it. Find out how many roses. So set it up the exact same way, but punch in a 520 instead of a 515.
Bottom, like the last parts of the.
Just get to the bottom and then I'll help you, okay? This is not one you really need to pay attention, okay? Good notes today? Awesome. Love those notes. Let's keep working.
Miss, like,
Yeah.
we don't have a calculator.
You have a calculator?
Here you go. We need a calculator. Thank you.
So sad.
I know, right? I just realized this.
So you're gonna set it up exactly like this, except instead of $5.15 a rose, it's $5.20 a rose, and then you're just gonna keep solving. Yeah, you're doing the exact same thing that we did, but instead of $5.15, it's $5.20. They just changed the price. They made it more expensive.
Yeah, keep all
Technically not time to leave.
What?
Oh, good.
Yes, it is.
Oh, good.
You guys.
Oh, good. I got 96.
Oh yeah,